Hi. Great. Oh, thanks. Good morning. Well, thank you for being here. I'm Adrian Lee. I'm the head of the ecosystem development at the PSE team. For those who don't know, PSE team is the team that previously known to be Applied ZKP, part of the Ethereum Foundation, and we've been working on developing the ecosystem essentially for the next little bit. So today I'm just going to talk a little bit about navigating the ZK learning curve, right? So first, let's talk about the learning curve. Who here has tried to learn ZK before? Who here has found it to be very easy? Much fewer people, of course. So we're going to talk about that, right? Because why is it so hard? What are the challenges that there are in terms of learning like things about ZK and how we can navigate around that? So let's take a look at some memes, right? Just to get things started, right? Wake you guys up a little bit. Whenever you start learning something, it's always really difficult, and during it, you feel like it's almost impossible, and that's where a lot of people give up. But then afterwards, you feel like it's not so bad. But then you kind of take a look again at the next time, it feels that way every time. And that's kind of a natural cycle in terms of learning anything. And I think most of us agree with that, right? Here's another one. This is actually from Eve online. You can see how they're comparing World of Warcraft, very easy slope at the bottom, and then you have some very difficult things. So maybe for us, the red line would be like learning HTML, right? Maybe green is like JavaScript, and then the black part is like zero knowledge proofs, right? So that's a funny meme there. Here's actually similar to what we had from the first meme that we have. At the beginning, like this is how positive you are about learning the thing that you want to learn. In the beginning, you really love learning it. It's really enjoyable because you feel like you're learning something useful. And then you get to a point down here where it's just really frustrating. You don't know where to go. And then you see this red line here. A lot of people give up. And that's what we want to try to avoid, right? But if you persist, you can come back up to slightly positive, right? It's not even that positive, but that's kind of like a lot of problems, right? And you notice as well that most of these memes are not about ZK. This one's about learning programming languages. The previous one was talking about like learning how to play games, right? And this is also, just for fun, we have different learning curves for code editors as well. This is something like, if you know type of thing, right? If you've never used Emacs or Vim, those things might not make a lot of sense, but, things can be hard is kind of the point of this. So, one of the problems I think, when I was trying to look into this topic is that there's just too many courses, right? There's too many ZK tutorials out there. You don't know where to start, right? So ZK tutorials everywhere, right? And then so you ask your friend. Maybe you have some people that are researchers or people who have done like ZK apps before, and like, oh, where should I learn, right? And they've got opinions, right? Everyone's got an opinion, right? Oh, you should learn this. You shouldn't learn that. Oh yeah, Starks versus Snarks. Oh, you should like just skip Circom, go to Halo 2. Or it's like, oh no, like you should use our DSL, right? So there's like so many things that, people tell you ZK learning is easy, just follow my tutorial. But there's, everyone has their own opinions on what to do, right? So like a couple more, learning ZK is easy. There are so many resources. Or like, you just look at another tutorial, right? The next thing you know, you've been learning intro to ZK for like 3 months. And then you're still thinking about Alibaba's cave and more like thought experiments and things, right? So how do we tackle this, right? So here's some context, right? Last year, we at PSE decided to host a program in the summer called the Contribution Program, so the Summer Contribution Program. And the goal of this was to grow the next generation of ZK open source contributors. What we did was we found university students, specifically because of our personnel at the time. We focused on Taiwan, South Korea, and Japan. And we were looking at university students with some programming background. They would have like a computer science major or a mathematics major, and we wanted to take them from a place where they have some basic programming knowledge, but they don't really have much understanding of ZK, but they are very curious and they want to. And we want to bring them to the point where they can make open source contributions at all, right? And that's why we don't call this a boot camp or anything like that, because the ultimate goal is not only to teach them something, but to help them become contributors to this space. And I think that's how we at PSE really believe we can have more impact on the world as well. So what did this program look like? We had like all these, smiling faces from Korea. Actually, like that's Suwon. He's going to present next. He's sitting up here about a topic that's much more technical than this one. Um, this is in Japan, right? We had a nice guest come with us as well. We took very many really nice looking pictures just to give you an idea. People really enjoyed the program and got a lot out of it. But so let's talk about the curriculum, right? Because that's the kind of meat of the program, and also I find to be like the most challenging part, right? Because I personally had to write the entire curriculum for this, and I didn't really know much ZK at all. So we'll see how that went, right? So this is kind of what we had last year. I'm not going to go through every single detail here, but basically we had like this intro. We go from like we're going to like talk about modular arithmetic, talk about some basic cryptographic primitives, and then we launch right into elliptic curves and ZK snarks. And then we talk about a little bit of our PSE projects as well, and how to write circuits with CirCom, and we have some examples for them to try out. And after that, we throw them into the open source and be like, hey, just work on some issues, right? So there was like a lot of experimenting going on because we didn't really know what we're doing. We just wanted to throw them into the weeds and see what happens, right? So here we have, this is kind of, we actually went through many iterations of the curriculum as well, because the way that we tried to come up with a curriculum at the beginning was we just asked all the researchers in the PSE, like, hey, what do you think they should learn? And then of course there were pages and pages and pages of things, right? All the way from like very basic things, obviously, like I said, just like ideas, like non-technical ideas about what zero knowledge is, and like, just modular arithmetic, and all the way down to, pairing-based protocols, very specific things. So let's see here. So there are 3 takeaways that I want to talk about for this particular presentation that maybe can help you guys or help your community make this ZK learning curve a little bit easier or a little bit more manageable for you. And here they are. I think number 1, it's important to know how to start and also when to stop with a solid foundation. I'll talk about what that means, right? And number 2, it's important to also build and break on day 1. Having that practical aspect at the beginning is very important. And number 3, I think this is the most important one. You really should consider everything as optional, right? Because if you dive into every single thing, you're basically going to get stuck in the weeds quite a bit. And there are a lot of weeds in this particular space. So the first one, what does that mean, right? To start and stop with a solid foundation. Well, I think one of the biggest feedback we had from our curriculum was that the learning curve was just way too steep. Week 1, we had this very simple thing here, 12 mod 5 equals 2. For those who don't know modular arithmetic, you can understand this very quickly. It's like 12 divided by 5. What's the remainder? It's 2. Okay, good. That's week 1, right? But what's week 2? Oh, okay. It's elliptic curve pairing with pairing-based cryptography, and you need to know exactly how this is happening, right? And this is already a simplified diagram, right? That's actually telling you to treat this as a black box. So, I mean, I think like people kind of had a little bit of whiplash from where we started and where we came to. So that's week 2, and then we had like another 6 weeks after that, right? So I think it's really important for us when we're learning anything to really black box things and really consider whether or not we need to dive into it, right? We don't need to step into every single little concept in order to understand the big picture. It really depends on what your goal is, right? And that's kind of navigating the difference between a top-down approach and a bottom-up approach. Because within the PSE team as well, a lot of people were saying how we should build things up from fundamentals and primitives. And then there are other people who said, just run the code first, get them to have a high-level understanding. And sometimes you need a little bit of both, right? And I think striking that balance is the hardest part. When you're not sure how to strike that balance, build, right? Because the moment that you try to make something, even if it's like a simple hello world type of program, you're going to realize what you're missing, right? If like, oh, you don't know the syntax, well, maybe we should at least learn the syntax, right? If it's something that, just writing a very basic circuit in CirCom, maybe you don't need to know the specifics of, all the different cryptographic schemes there are that we're talking about, right? So that leads into the second point, which is we should build and try to break things on day 1, all right? one of the issues of the program we had was we didn't actually start doing any circuit writing until I think 3 weeks in. And by that time, like, people have been basically studying textbook knowledge for 2 whole weeks. And so it's been like, quite tiring for them. And then we just throw them into Circom and be like, oh, just do it. And of course, that was quite challenging. So, okay, let's do Circom, right? Like, you have no prior experience, and you look at this is actually from the Circom documentation, supposed to be really easy. And if you've kind of done some of this before, it does look easy. But, maybe if you're just trying to learn the syntax and write a very basic circuit, you don't need this. Maybe, you can use a shortcut, right? So one really good tool is ZK thanks to ZeroXPark, and you can actually just do everything in the browser. Right? There's no need to like go into the command line, install snark.js, and there are a lot of issues with the tooling that may not be as smooth as usually it is, as people might expect. But like with zkrepo.dev, you can just go there and like run every code you want, right? So the idea is just make something first. You don't have to make something that's really complicated. Sometimes people go into it thinking it's like, oh, I want to make a token mixer, right? And then that's kind of like the one thing they want to do, right? But maybe, you don't have to do that, right? Because you can always go back to the hard path afterwards. You can always download snark.js and run everything yourself locally afterwards. Once you're comfortable with the Circom language, a lot of the tooling things will become something else, right? Will be a little bit easier. So everything is optional, right? When we wrote this curriculum, I tried to really put in a lot of content that people would want, and then so what happened is that we just mark everything as optional, but because we had it in there, people still really wanted to like watch all of it. And I tried to put these minute markers, right? How long these like YouTube links are. And you can see like just this bottom part here is like 2 hours long, right? So are you really gonna spend 2 hours on this optional thing, right? And then there's also like 2 long blog posts up here. I think they're really important for understanding the concept. But maybe we can just focus on one and leave the other one as optional as well, right? So that's some of the changes that we're doing for this year's summer program. And then there's people who just wanted to write like Circom, like really basic Circom things, and really just understand the basics of what's going on. But do they really need 6 links to learn about BLS signatures? Probably not, right? So I think one of the approaches that we're taking, or we've learned from feedback, is that it's important to like just leave things as optional and let people dive in when they feel like it, because there's always a balance to be struck between giving structure and then also giving optionality. So maybe this is all they want to do, right? And like I think I can anyone here like completely non-technical can understand this as well. There's like the constraint, you see it must be like A times B, and then so this is a circuit that proves that A times B is equal to C. That's it, right? And then so you don't really need like 2 hours of YouTube videos and like 6 different blog posts to tell you that. So this is kind of cliche, but I really like this quote from Antoine de Saint-Exupéry: "Perfection is achieved when there is nothing more to add, not when there's nothing more to add, but when there's nothing left to take away." So we want to really cut down as much as possible on what people need to learn and just give them the optionality to do that. And I think it's important when you're self-learning to do that for yourself as well, right? So what does the new curriculum look like? Well, this is kind of a very basic overview. Oops, here. Yeah, so first what we're going to do is that we're actually going to take a lot of the easier stuff, like modular arithmetic and stuff like that. We're going to put it as a prerequisite. So there's a module 0 that the students will have to do at home, right? And then when they get in week 1, then we can actually get started coding in Circom from day 1 with ZK so they can just start getting used to building things. Whereas previously, we waited until like the 3rd week. So that's, and then we also broke it up in week 3 with a hackathon. So we actually have like 2 full weeks of studying. We have a hackathon, and we have another 2 weeks of studying, right? What this allows us to do is like, we can actually be more confident in making the weeks more rigorous. So previously, we didn't really have time to dive into Plonk as much, but for a lot of people here, we know how important that is to understand, right? At the same time, we didn't even have much time to touch on Halo 2. We had to make them pick between Circom and Halo 2, which isn't really ideal either. But now, because of the way we've broken it up, we have a section on that in our curriculum here too. So that's why like we moved a lot of stuff into prerequisites, so we can really focus on what is really important here. Also, I forgot to mention, like previously, if you see like the modules that we had from the old curriculum, things were happening in each module of half weeks, so 2.5 days per module, right? And that's super confusing, of course, right? You know, you start something on Monday, and then like midday Wednesday, that's supposed to be finished, and you're supposed to start the next module. So we're just going by weeks now, and we're just, in this way, like people have more flexibility in terms of how they can move around with the topics that they like to talk about. So fewer week-based modules, students complete a module before the program starts so that we can have more time to focus on the deeper things. And we also broke up the program with a hackathon. Students start writing circuits on day one. So these are some of the applications of how we changed our curriculum based on the feedback that we had from the program last year. So conclusion, I guess this is pretty quick presentation. You know, these are the 3 takeaways. Know when to start and when to stop. You need a solid foundation for sure, but you don't need to go into every single thing. And if you're not sure what that means, you know, try to build something, right? And I think it's important to build something on day one, and also realize that everything is optional. You know, a lot of times, you know, as adults, I talk to some other people. I was like, oh, hey, what books are you reading? And then they say they don't read anymore. And I think a lot of people actually have this bad experience from school or university when they're required to read a book in full. Right? But these days, when I read something or learn something, I just flip through. You know, I can stop anytime, right? No one is stopping me. So it's important to realize that it's the same in anything you do in life as well, right? Everything really is optional. It really depends on what you're trying to do and what your goals are, right? Even if you're being, you know, you want to be a researcher in a specific topic, you know, you probably need to ignore certain other topics so that you can focus on a topic that you want. So I think that's a really key takeaway, at least for me personally too. So, you know, what are we trying to do with this curriculum, right? We want to create a future where we have all these new ZK engineers and researchers. We want to create a scalable curriculum as a public good as well, and we want to grow the communities. So, before we get to that, actually, this is an old screenshot, but we have a Good First Issue tracker that will allow you to work on Good First Issues from PSE projects, so that you can get involved and see how you can, you know, contribute to open source. I think it's gfi.pse.dev. Unfortunately, I forgot to put the URL on here, but you can see we're going to link it from the main page of pse.dev, and the UI is different as well. But you can see there's like a lot of issues that you can work on and just poke around in. And that's actually what we did for our summer students too. So the results of the program are, you know, about 50 people finished it, and 90% were like new to open source. Like they never use, or maybe they've used GitHub before, but they never like made any PRs. They never wrote any issues before, right? So that's why that Good First Issue list of Good First Issues was so important. Yeah. So with this program, by the way, like we developed the curriculum with student feedback, as we talked about, but also after that, we give some of them learning grants so that they can keep on developing their expertise within the space. And beyond that, we have specific projects, part of the acceleration program, where they can work on and get a grant to work on those projects and develop their expertise in a certain area. So, I think this summer program, and specifically this curriculum, is a really good way to get people started, to get to the stage where they can feel comfortable contributing something to open source. So what are the next steps for us? Well, we're actually expanding, so we're doing Latin America this year. I don't quite remember the countries off the top of my head, but I believe it's Costa Rica, Ecuador, and there's one more, but unfortunately I forget. We will also run it in Tokyo, Seoul, and Taipei again as well. And like the great thing is that we're going to have previous years students to help lead some of that too. So hopefully we can create a more self-sustaining type of process here. And of course, we want to build a local community. So thank you for listening to my presentation. If you want to see the curriculum, it is open source. We do want to give this out to other ZK study groups around the world. So do scan this QR code here. It is still very much a work in progress. We still have to update the new content, but that's where we're going to host the curriculum, and we're probably going to do a little bit more advertising as well or kind of marketing to tell people that we have this curriculum. But I think it's a really good place to start. And well, thank you for listening to my talk.
So, so does anybody has any questions? Yeah.
Hi, Adrian. I've gone through the ZK Playground course here in Taiwan that the PSTME East team also sponsored and contributed to, I believe. And your modification to the curriculum really makes sense to me, like start hacking from day one. Um, uh, but I was wondering whether you've gone through too many programming languages within your curriculum. For example, learning Rustlings.
Sorry, I can't hear you.
I was wondering if learning Rust in 1 week from the Rustlings tutorial may be a bit too much for students. So they have to learn like 2 programming languages, Circom and Rust.
Yeah, so that's why we actually, from the new curriculum, we're doing CIRCOM like from day one. So by the week 2 or 3, like we can, they're hopefully more like familiar with CIRCOM already, and then they can switch over to like, they're not only just doing Rustlings, right? They're gonna do Rustlings and they're gonna do a lot more deep dive into how to work with Rust and things like that. I think 1 week to learn all of Rust from scratch, is obviously very difficult. But also, this is just to give them like something to start with, right? There are a lot of people, depending on what they're trying to work on, that they maybe end up not using Halo 2, not using Rust at all, right? And if they're really comfortable and they have, they have all the skills required to do what they want to do with CIRCOM, maybe they don't, right? But that's another thing to keep in mind. With this particular program, we want to keep things open, make sure like we introduce them to things that they can dive into, but everything is optional, like I said, right? So again, like not everyone needs to learn Rust, not everyone needs to learn Halo to contribute to the ZK space, and I think that message is important as well. But yeah, thank you for your question.
Does anybody has any questions?
Yeah, hi Adrian. I'm a Rust developer and I came across the PSC acceleration program that's happening, and I came across the issues list on that. And to be honest, it felt a little intimidating for those issues for me to tackle those issues. So would you say this course would be a good starting point to get across to those issues on the PSC acceleration program?
I can't really hear. I think the echo is kind of strong. Yeah. Sorry.
Yeah, I'm saying I'm a Rust developer. Yeah, but I came across the PSC acceleration program issues and they felt a little intimidating. So would you say that this course would be a good stepping stone to work towards that?
Sorry. Yeah,
The
tell me without the
echo
mic.
is too loud.
Yeah. Right. Oh yeah, the topics are very tough. I think so. Yes. So the question, I'll repeat it, was that the acceleration program has a lot of topics that seem quite difficult, and the question is whether or not the course is a good intro to that. I think it is, but at the same time, I think we also recognize that not all the topics in the acceleration program are quite easy either. So there is a bit of a gap, and that's why, like for some of the students, they took a learning grant to kind of, bridge that gap, right? The acceleration program is designed for people to build expertise in a specific topic. So if you don't have the fundamentals to do that, then it's going to be quite difficult, right? So to answer your question, right, it really is, the acceleration program is kind of like where we're dumping a lot of random ideas that we think people can work on, but it is a very large variety of difficulty as well. The program itself, the curriculum I talked about, I think gives a really good foundation. But at the end of the day, like I think I really need to stress that it's really important to build the skills to self-learn, to bridge those gaps to those particular topics, because it is a space that's moving quite fast, and so there's no way we can have a curriculum that will prep you immediately for these ideas that we want people to build on. I hope that answers the question. Thank you.
Thank you so much, Adrian Lee. Thank you.